Yes, thank you for having me. As was mentioned, I'm going to talk a little bit about the subjects you can see up here. Standardization, digitalization, and productivity, and the connection between these things and how they are related to international standardization. For a company called Molio, it's a result of a merger took place about 3 years ago between something called BIPS, which was an organization in Denmark for companies in the construction industry. So BIPS had around roughly 600 member companies who were architects, engineers, contractors, product manufacturers, software companies, clients, and so on. And BIPS was merged with something called Byggecentrums, which was a foundation which had the main purpose of publishing information concerning construction. And you might run into some of our tools. BIPS published a lot of different tools around CAD, BIM, classification, ICT agreements, and stuff like that. Byggecentrums has published what was previously known as the BRS, price data, which is the books used for cost estimating. You know that the program Sigma, which will be described later today, that program contains price data from VS, which is currently called Molio price data, and we also have some other tools in different areas from Byggecentrums. Another thing that we're working on at Molio is that we are part of the International Building Smart organization. How many of you know Building Smart IFC? Yeah, about half of you can see. Well, Building Smart is an international organization who works on making open formats for exchanging data between primarily building modeling systems. The idea behind the Building Smart, which I will get back to, is that instead of using the proprietary formats from, for example, Revit, which you probably all know, then if we have some open formats, it will be easier to change information between different software platforms and thus making the data more accessible for the different parties. As in Building Smart is organized in an international organization, as I mentioned, and in Denmark we are a part of the Nordic chapter, and Molio is the organization which has that role in Denmark, and I'm part of the board of the Nordic chapter, as I will get back to just in the next slide. I'm educated as a construction engineer, and my primary experience is I've been working as well, it used to be my primary experience, now I've been doing this for so long, I have to change that slide. But the thing I did before I got to BIPS and Molio was that I made a cost estimating system for contractors. As I said, I was originally a construction engineer, but since 2011 I've been working for about 4 years at something called the Cunigo project, which was an EU-funded project that BIPS carried out, and where we developed something called CCS, classification system or entire system for handling information structures. And since 2015, the Cunigo project ended. I've been what is known as Chief Product Officer at Molio, and that's to say I have the responsibility for the development and the operation of all our digital products, price data, BIM tools, specifications, and other tools. This is just a short slide about the role of Molio. We are a not-for-profit organization. We don't have any owners, we don't have any shareholders that we have to pay money for. Every euro or only we make, we put back into the development of our tools. So we're the only party in the construction industry who is neutral. We're not organized so that we belong to the architects or the contractors or any other parties. And therefore it's possible for us to take on roles where we develop something that is for the common good, and as you can see up here in our vision and mission, What we aim to do is increase the productivity in the construction sector by making open standards and information handling. And that's a lot of the things I'm going to talk about today is based on that. This is actually it's a quote from a movie. I don't know if you know who that is. You're probably too young, but it's the actor Michael Douglas, and it's from a movie called Wall Street from in the 80s, where we had this statement: the most valuable commodity I know of is information. And I think even though he was a bastard, and it was a long time ago, it still holds true. So the idea about everything we're working with is to turn information into something that is valuable for the people who's going to have the interest in this. And as I will get back to, this is to a large extent the clients, the people who own the buildings or the other things being built. They are the ones who are the customers, and they're the ones who handle the economy and the main part of the economy in the project. So we have to look at the value of the information in respect to the clients. Another statement that we've heard over the years is standardization is the precondition for digitalization. We can't make digital standard and digital tools without having some sort of standardization. And this is becoming more and more true. And one of the guys who said that was this guy, Tom Flickor, who used to be the managing director of the Conigo project and BIPS, and another person is the picture disappeared. That was the CEO of Microsoft in Denmark, who's also had that statement. And I could probably find a lot more people who would say the same thing. So digitalization as a precondition for productivity. Is there a link between digitizing things and having a larger productivity in the construction industry? This is a report from 2010 from the Danish Business and Construction Agency, I think was the name back then. And this was basically the foundation for the Conigo project, where back at that time there was this idea that the way to achieve greater productivity is by having digitalization of the industry. We can look at this slide. This is a comparison of the digitalization of different industries. You probably can't see all the names of the industries here, but these colors shows how much is the individual industries digitized. And of course, the green ones are the ones who are furthest ahead, and the red and yellow ones are the ones who are lagging behind. And the one you can see down there is the construction. Yeah.
From when is these graphs made, basically? Like, how old are they?
I think they're a couple of years old. It's pretty recent.
Okay.
I think it's from a survey from McKinsey Global Institute, but it doesn't say what year it is. But I think it's from about 2 years ago or something like that. They're not very surprising. The most digitized industry is ICT and media and finance. But at the bottom we have construction. And this is another slide which shows something about the relevance, the timeliness, and the readiness for digitalization of the construction industry in different areas of the world, where we can see that North America is furthest ahead, and Northern Europe, where we are lagging behind to some extent. This is another slide. I guess you've seen it before, about the productivity in the construction industry and the development of that from the mid-90s until 2010. But I guess that it hasn't improved significantly in the last couple of years. And from about here, we have been digitizing the construction industry. So if you look at that graph and the rise in productivity, you would say we haven't been doing much good over these years. So is it really true that there is this relation between digitalization and productivity? What I'm going to talk about, to try to tell you, is that it hasn't improved very much yet, but there is a reason for that. Maybe we have had the wrong focus, and maybe we haven't had the right basics for doing this in the right way. So I'll get back to that. The way that this productivity is measured is the value added per worker, because productivity can be regarded as many things. Just look at how many square meters do you produce per worker. Then it depends very much on what are you building. But in this case, it is something saying how much value has been put into the project in terms of what can we sell this for in relation to how many people have been working on it. And that's the result there, where it hasn't changed significantly in all these years. So, the other thing that I'm going to talk about now, and for the most of the time, is standard as a precondition for digitalization. So, how do we make the digitalization greater by having common standards? That's something I'm going to try and talk about. This is a tree or a graph showing the relation between knowledge and information and data. Well, at the bottom down here we have data which is singular observations or facts about different things, not put it into any context. So the data can be the width and height of a window, the thermal transmittance of a wall, or something like that. But we don't relate it to anything. We just consider it as basic data. When we start organizing it, we turn it into information. So if you put it into a context and put some classification on it and maybe link it to a model, then it becomes information that says something about the things we're interested in. And then when we interpret that information and use it in a context and use it for something, then it turns into knowledge. And these are important things when we consider how we're working, how we're doing digitalization. Because when we look at it, we have different layers. I like this graph where they put it into 3 different stories in a building. Where at the bottom we have the data, we have terminology, dictionaries, classification. So that's the basic things we are operating with. And to get to the next level, we can use BIM objects. Not specifically from company BIM objects, but BIM objects in a larger context where we, for example, in our companies, we organize our information about what we are designing into some objects. We could put into the Revit families, we could put properties on it, and start using it like that. So we take this basic data and we turn it into some units of information that we can use in our projects. And then we get to the next level, and this is the end-to-end. That means this is a machine-to-machine interpretable. So we don't need human beings to do this. We can make some objects which the machines can understand and we can work with. The next level, we use different standards. In this case, we have 2 standards from Building Smart. IFC, which is a data model for exchanging data between different applications. And the other one is something called BIM, collaboration format, which is a standard for exchanging specific units of information between different parties in a project. So if I want to I work on a project and I want to tell something to somebody about a collision between some objects, instead of sending them the entire building model and saying we have this beam on this wall, and there's a problem with that, then I can take a snapshot or an extract of that particular part of the model and send it to somebody else, or I can put it on a server and somebody else can access it and look into the problem. So this is another technology from Building Smart that is very, very suitable for cooperating between different parties. So that's something you should definitely look into. So we have these standards here on the information. Yeah.
When we're looking at these different layers of information, are they somehow related to, for instance, the BIM level 1, 2, and 3 seen from the UK standards? Are they related in any way?
Well, they are because when you get this model working in an automated manner, you can go to the BIM level 3 or 4. But this is a precondition for doing that, because if you don't have the tools to understand this, then you have to have human interaction in order to exchange information, and then you're back to BIM level 2 or BIM level 1 according to the British standards. So this is then to get from this layer where we have the information, we have the data connected to a model. To get to the top level where the people are, we need some interpretation of what are we going to use this data for in a context. And that's where we have this Molio definition, which is another Building Smart standard or tool, where we take the model and say we need to look into this specific topic. So we take all the pieces from the model that relates to that topic, and then we can look at the information in that way. Because if you just get the entire data model and look at that, then it would be too hard to use it in an actual context. So to get to this layer where the people are and the money are, you need some interpretation of this information related to something that somebody wants to do. Up here we have the things that the people are working with, BIM execution plan. That's similar to the EQT process manual, we know from the Danish context. And there is something, a new standard, ISO 19650, which is very relevant in this context, which I will get back to. This is another slide, I guess you probably have seen before. It's hard to say. It's hard to see, but in here it says cost of ownership, because it can be tricky. But the basic idea here is that if you look at this this entire square, it's the total economy of a building or something that somebody has designed and constructed and is owning. This is the price for building the thing, and this is the price for designing the building. And what we're suggesting is that for very many years, from the start of the 90s until a couple of years ago, all the focus when working with BIM has gone into looking at the cost of design. What are they doing in the engineering companies? What are they doing in the architectural firms? Not very much about how do we improve, how do we build more efficiently, and even less about what can we do in order to make it more cost efficient to run this building. So this is something I think is part of the reason for the graph we saw earlier on, where there hasn't been much improvement in productivity for all these years. That we have had the wrong focus. We haven't been focusing on all the money that is lying there. If you look at this graph and look at the economy of a building, then you can see that if a building costs 100 million kroner to build, and you can, by using the information for operation and maintenance in a more efficient manner, you can improve or reduce the cost of operating it for let's say 10%. That's not very high related to some studies that have been made. Then you can say that for a building for 100 million kroner, the total cost of ownership for entire lifetime would be 1 billion. And if you reduce the operating cost by 10%, that would be 90 million kroner. So if you had to sell a building to somebody and you could say, well, I have this building, I don't have any information any information for operation and maintenance, and then I have the same building which I could sell with the information you need for operation and maintenance. You could actually sell the one with the information for 90 million kroner more than the other one, and you just don't do that. You don't appreciate information. You don't have the perspective that if you get the right information along with the building, it has a far larger value because it will be cheaper to operate. And I think that's one of the main reasons that's been very little focus on that part. This is just something about the way we have been making these requirements over the past few years. Look at the national requirements in Denmark. If you take pictures, you will see that the things that a client is required to ask from the people who make the project for him is something about classification, identification, properties, level of information, stuff like that very few clients have any understanding about. I think that it would be a much better idea if you did this and you said that if you want to have information about cost of ownership, quantities, energy, performance, and so on, you have to pay a certain price for that information. We were talking with some of the clients for Byggeforeningen, and they're actually willing to do that. They're actually willing to pay for the information that they get if they know they can use it for something. The problem right now, when you make these sort of requirements, is that you don't really know what you can use it for, and then you don't have a very strong demand for those things. So we actually suggest that you did something like that. That you have a cost for this information that the client should pay. I talked to a guy from Copenhagen Airport who was in a meeting in Gatwick a couple of weeks ago, and they have actually made a calculation that said that a property on an object costs £10. So they pay £10 for the properties they get, and then they can decide what they think the value of that is, and to make agreements about on that level. So what are standards? This is a slide displaying what the user standards are. The idea is here that you start out there by having a specific problem. We have something we need to solve in a certain context. We just solve it right here and then go on, and then in a few days we'll have the same problem and do the same thing over again. Another thing you can do is to look at this specific problem and turn it into an abstract problem. Say, what is the issue here? What is the general issue that causes this situation? And when you've done that, you can make a standard describing how do we handle this issue. How do we agree on how this should be done so we can do it again and again. That you can turn into an abstract solution, which could be, for example, a software tool or some other tool that you can use in the context. And by using this tool, you can solve the specific problem. You have a specific solution you can use in the projects. So the idea about standardization is that you don't use standards directly. You use standards to create something that can help you solve your problems. But by doing this, you can make the tools in the same way, and then you can have companies competing on making solutions for these problems, but they do it in the same way so that people using them can switch between different applications, for example. I'm going to talk a little about these 5 standards. I'm not going to go into too much detail, but there's time for questions afterwards. So if there's anything specific you want to know something about, you could just ask. The first one I'm just going to mention here is something called ISO IEC 81/2 and /10. And the reason I'm mentioning this is because this is actually a part of the output from the Conigo project I mentioned earlier. The classification tables we made in the Conigo project has gone into this international standard. So the work we did back then 5 years ago is now adapted in international standardization. The next one is the IFC standard, which is used for data exchange, as I mentioned earlier. Then I'm going to talk about some standards that are being worked on in a European context. These two about property dictionaries, one about information delivery manual. If you remember the slide with the different stories in the building, this is where you get from the middle story to the top story. And then finally I'm going to talk about this 19650, which is about how clients make information requirements. This is something that is extracted from the IFC standard, which says something about how objects are related to each other, what entities you have in IFC, and so on and so on. And very few people look into this. This is for software developers. So if you use the IFC standard, you don't use it like this, you use it like that. This is a snapshot from the Solibri model checker in the building, and you can see the building, you can see this, reading this window in the building, and here you can see some properties for this window. And this is Solibri, the model is made in ArchiCAD, and you can look at it through 20 or 30 different tools, and you will get the same results. And the reason you can do that is because this information is structured according to the IFC data model. So the standard says this is the way you're going to structure the information, and then all the software applications know where to look for the different parts of information. So this is the traditional way of having standards. This tool is something that we've been working on in Molio. Well, actually, we have some people doing volunteer work. Thomas Raubæk for Bimequity, who are the ArchiCAD supplier in Denmark, and Niklas Søstergaard from Smith-Hammer Lassen has actually been doing most of the work. But this is a guide, and the idea for this is to have a tool that people in the industry can use in order to use IFC in the same way. Because even though IFC is a standard that says something about how information is structured, when you just have people making models and exporting them to IFC, if you don't do anything specifically about it, then they will make very different models, and it will be hard for the people who receive the models to understand where to look for things. So this is something you put on top of the standard. So we have a standard, but you need to look into this in order to use the standard in the same way. Yeah.
Do you see the IFC guide as part of like something contractual that people actually have to do this way?
No, I think I see it as a guide. If you have something contractual, you have to write it into the BIM execution plan or the ICT specification. But this you can use this as some information for how to work, but the specific demands should be written into the ICT specifications. This is something, a slide describing some work being done in the European standardization, CEN TC 442, which is some work that was started some years ago. The original idea behind this was to take all the standards from Building Smart and put them into European standardization. Before that, they were ISO standard, that is international standards, but the difference between ISO standards and CEN standards is that when you have European standards from CEN, then the EU can make those standards mandatory. So if you have something as a European standard, then the EU Commission can say this is mandatory in the EU countries, and then it's suddenly something that you have to do and not something that you can choose to do. So the idea for putting all this Building Smart work into the European standardization is to make it mandatory or make it possible for it to be mandatory in Europe. So there's a lot of work going on here. Exchange information and working with something called level of information need, which is similar to LOD or informationsniveau in Denmark, so there'll become a European standard for that. Information delivery specification, again, was where we got from level 2 to level 1 in the building. And then we have a working group 4, which I'm a part of, which work with properties. How do we harmonize the use of properties? And that working group 4 is working with these 3 different standards here that I'm going to describe very, very briefly for you. The reason why this is so important, this work concerning properties, is that when you actually have to exchange information between different parties in a project, it is very important that you have the same understanding about that information. So if you talk about thermal transmittance, you have to understand that you have to agree about how do we measure this thermal transmittance, because thermal transmittance can be measured by different methods if you use different standards. So if people exchange information in the project and they don't agree on what I'm doing here, then there will be misunderstanding because a value will be interpreted wrongly. So this is, I think, this is actually the most important part about all this exchange of information in the industry. Of course, we've been working a great deal with classification, but there's no problem that you can use different classifications for the same object if you know that there are different classifications. But you can't use different properties for the object if you want to exchange information with each other. So this is then the things that we're working on in the project. One is that what sets of properties are required for each product type, because different products have different properties. You could open a window, so whether a window is openable or not is relevant, but there are a lot of other things that you can't open, so they don't need to have that property. So you need to identify which properties do we use where, and another things that work very much on is how properties are defined. So we make sure that we just don't make our own properties, but we have a procedure for making sure that the right people are deciding what properties do we need. So this is something that this standard is talking about. And this slide shows the levels of legislation here. What is more mandatory in what? On the top level is the European legislation, where we have the construction product regulation, CPR, the low voltage regulation, and so on. This is law. You can, as a product manufacturer, you can't sell the product in Europe unless it is approved by some common CE standards. The next level is national standard, and the third level is market requirements. So these are things we have to take into consideration. The next part of the standard, the second from the original slide, is this information structure. How is the different, how is metadata for properties related to each other? And this is of course necessary in order to have a language where computers can exchange this between each other. And the third is the construction products regulations, product data templates, where we have some properties for products which are essential characteristics. So this is something that we have to have information about, and then we have non-essential characteristics where it's not mandatory to have these. So the third part is about how do we handle this in relation to properties for products. And how do we exchange this? Well, we use the IFC. So on one hand we have the IFC standard, and the other hand we have these all these properties for products. And then by using the objects in IFC, we can relate, in this case, the information which is relevant for insulation to the right objects in IFC. So here we use the data structure that was defined in IFC in order to exchange this information. And then when we get to the project level, it is possible to use, again, the IFC to exchange this. So we have this model and we want to put a property on an object, and then we look into the structure and say, where do we put it? And then we get, through IFC, we get the information back, we can put it into our object in Revit, and when we at some time export the IFC model, it will be placed in the right way. And this is something that this Zen TC442 work is covering. This is a snapshot from, or a screen down from the database we have created in the Kinigo project, where we actually have the same issues. We have this fire rating for a beam, and here we can see which standard is it defined from. What is the IFC name for the property? Which properties does it belong to in IFC structure, and so on. So this is a database where people can access the properties and see how they should be named and used. But we also have a value list for this fire rating. And if you look down here, you can see this one is at the bottom of the screen. You can see we have also put Revit widths on these properties. So if you exchange Revit models between different parties, then you can get the right widths. So the different installations of Revit will interpret these as the same parameters. The next part is now where we've got to the top level of the building, where we're talking about how do people use this. In international standardization, they're talking about something called purposes as a definition or a concept for how do we exchange information with each other. And this is, as you can see here, this is a basis for structured exchange of information in relation to a specific process, where the idea is that you look at something specific that somebody wants to do, and then you have a method for accessing the information that is relevant to this process without looking at all the other information that is in a model. So the common way of working is in a project is that at some stage in the project you have an object that could be a wall or a window or something which you need to work on in your design phase. As an architect, you need to create or do something with a window in a project. So this is one purpose that you're doing your design. Another purpose can be you want to do some analysis and calculations and some simulation. So where you start out is that somebody else has done something before you in the programming stage or another time, and you get some information from him that you start working on. And it's at this programming stage, for example, you have also done some analysis or some work that has delivered some information that you can use for a purpose. In the design phase, or at this project stage, you have an output, you design your object, and then you do something with it. You make an analysis. You say, if we make a window like this, what will the energy performance of the building be? And then you get some results back, and maybe you do it again in order to get the right results. And then when you're done, you have an object which you can send to somebody else, send it to the contractor, send it to the engineer, and you have a result that you can display that I've done my energy performance calculation, and this was the result. So this is a basic way of working with purposes. In CCS, we described a number of these purposes where we described generally the processes, and then we described a process diagram, what's going on in this, and then we made these sheets about what objects are concerned and what properties do we need for these objects. And this is created in accordance with the IDM method in Building Smart. So this is a way of describing, if we want to do something, how do we handle it through data? And we've also made a sheet where people can create their own purposes and work with that. And one of the benefits are that a customer, instead of asking for classification or information level or something, he can ask for something that he actually has an understanding of what he needed for. it's made precise what a consultant needs to deliver, and it's easier to establish whether a delivery is in accordance with what was agreed, and it's easier to customize or makes templates for working in different ways because it is agreed how we do this. And this has actually been implemented in this standard we have here. I mentioned earlier the 90650, which has been a European standard last year, and which could turn out to be something that is quite mandatory to work from in Denmark. So this is a great influence on our ICT specification and our ICT process manual. And the basic idea here is that this slide you have here, where we have an organization, this is the client's organization, and they have some information requirements. They have some rules about how do we do things, what information do we need to do it in the way we want it to do it. This turns into what is called the asset information requirements. So this relates to building, it can relate to ventilation plans, it can relate to individual building elements, but it says something about what information do we need for the objects that we want to operate. And the organizational information requirements contributes to what's called the project information requirements. Down here we're working on the project. So this obviously is something about what do the architects and engineers and contractors need to put into the project in order to meet our requirements. And this turns into the exchange information requirements, which is similar to what I mentioned earlier, these purposes and MVDs. So this is information we need to exchange from each other. And this specifies the project information model, which is basically the BIM model. And at some stage, when the building is done, an asset information model is handed over to the client. So this is not. He doesn't just get the Revit file or the entire IOC file. He gets an abstract from the building model, which contains these AEM asset information. This information that was generated here. So by looking at his asset information requirements, we know what to put into this asset information model. And this is important because if you just hand the entire building model over to a client, then he gets far too much information. There's a lot of things in the building model that he don't need for operation and maintenance. He needs maybe very few properties for the objects in order to operate them. So if you give him too much information, it's actually a big pain for him, because if you get too much information, you need to maintain too much information, and that gets very expensive. So it's important to know the distinction between what do you need to operate a building in relation to what do you need to build the building. Those are two different things, and I think there hasn't been enough focus on that. So this shows the life cycle, where here at A we start the delivery phase. The project starts, it's being designed and constructed, and then when we go to this stage, we deliver the building, and then we have the operation and use of the building, and at some stage we might want to make some renovations or do something else, and it goes all over again. So, but this is the project phase, and this is the operational phase. And this is something, just a short slide showing how the logic is here. When you deliver something that you state what you want, you plan how and when to deliver it, you get some information, you look whether it's okay or not. If it's not okay, you go all over again, or if it is okay, you better get on to the next stage. So there's not very much rocket science here, but this is good to have these things in order. And the potential for the digitalization is that if we specify these things in a standardized way in digital formats, then we can make these checks automatically instead of having people looking into the data and improving it. And we can say, we get to this stage, we have a description, a data format describing what should be delivered at this stage, and then we can check it through a computer, and we can do it far more efficiently than if people have to look into the information. And the basic idea, this is that you have different parties in this standard. You have something called the lead appointed party. This is the party that is working together with the client in order to agree on what to deliver. And then you can have other appointed parties. You can have subcontractors. You can have other consultants working on the project. We have these exchanges several times in the project, and I think you already know that this is something that's quite common. That if you look into even a fairly large project, you have a lot of different information handovers throughout the value chain. So this is handled through this standard by using these methods. There's another thing that's being described very specifically, or an important thing of this standard, and that's called the common data environment, which is somewhat similar to what we know as a project web in the Danish context, but with more rules for how do things get distributed, how do they get reviewed and approved and so on. So this standard also says something about how do we work here. And the reason I'm going into some detail about this standard is because this is somewhat different from the first slide I showed you with the IFC standard, where we have this standard that have a lot of different relations between some objects that software programmers can look at. When we look into this standard, this actually says something about how we're going to work. So when you get going out into the industry in a couple of years, then you will actually have a standard like this saying how do people cooperate in projects, how do things get approved, what do we call things, and this is all written into this European standard. So this can be very important, and as I said earlier, if this is going to be a harmonized standard, then it's something that is mandatory, and it will, as I said, have a very large impact on our way of working. There's also a part 2 to this standard, and that consists of some very specific diagrams showing the relations and handovers of information between different parties at different stages in a project. So this gets to a very, very specific level describing how companies interact with each other. All this is based on some British tool called HAS 11992. HAS is something called a publicly available specification, which is not a standard, but it's something prior to a standard. This was developed about 5 to 10 years ago in the UK, and when they saw the way it was going with Brexit, it suddenly became very important for them to get this thing they've been doing into European standardization. So the British have been working very hard on getting this standard approved in the CEN. And what's somewhat funny about it is that if this gets to be a harmonized standard, then all the countries in Europe, in the European Union, can be mandated to work by a British standard that the British don't need to use themselves. so this is actually quite clever from their part, because this is, of course, having an impact on standardization, or it has also some impact on your ability to compete, because if you know the standards, then you have an advantage to other parties. And this is just 3 tools that we have made. Some of the tools we have for client requirements. One is something called data to draft, data for operation, where we have been looking into operational processes at some different organizations, and we've turned this into some specifications of what information do they need in order to do their operations in this way. So this is a tool that was released late last year. This is something that we're working on right now. This is a hearing version, which will be published in a couple of, in this quarter 3 this year. And this is something about describing what demands can a client make that it actually has some value for him based on experiences. And the last one is this ICT specification, which describes how to make ICT requirements for a client to the different parties in the project. So back here, the tools I just showed you from Molio, they're lying up here in this level. We have the IFC down there and all the data in the bottom level. Yes? Questions? Any insights on relevance of this in relation to what you're doing?
Regarding the facility management organizations around in Denmark, for example, like hospital who has a facility management organization, do you see a maturity regarding the usage of not BIM but the information that we can deliver by using BIM towards their own operations? Because there is a lot, you've spoken a lot about what we can do, but what we can deliver to them. But I'm not that sure sometimes that they are ready for it.
Well, I think that if you look at the average of maturity through all major clients in Denmark, I would say that the level is not very high. But I think there's some peaks, and I think that if we have some organizations who understand this and start using it, I don't think it will be that hard to get other along, because if you can see that somebody is doing something and they actually have a benefit, then it's far more easy to do something yourself than if you have to listen to a presentation like that and try to turn that into the relevance for your organization. So I think that some of the organizations we're talking about are pretty much focused on this and are pretty good at handling it. We have a newsletter at Molio today. You can see it at our website, molio.dk, where we have 2 people from Copenhagen University, from the operations maintenance organization there, where they talk about their need for data and the way they use it. And that's one of the organizations we look at, which is pretty advanced. DTU in Lyngby are also pretty good at it. Yes? Well then, thank you very much.